Modeling linear relationships. Learning goal. I can use tables of values, graphs, and equations to describe situations. So we're asked to choose a 2 by 2 square of numbers from the 100 chart. So that's basically saying let's choose a square like that. And then describe the number at the bottom right in terms of the number at the top left. So in this case, we might say the number at the bottom right is 11 bigger than the number in the top left. Now they say think about moving the square so that the number at the top left increases by 1 each time you move the square. And then model the linear relationship with a table of values and a graph. So let's go back to the table and we're going to move our square over 1 so that the top left has increased by 1. And we can see now that when the top left increased by 1, the bottom right also increased by 1. So let's go ahead and create a table of values. So we had 1 and 12, 2 and 13, 3 and 14, and so on. And we want to graph that on our graph. So starting off, we've got 1 and 12. So over 1 and up 12. Then over 2 and up 13. Over 3 and up 14. Over 4 and up 15. And for part C, it wants us to model the relationship with an expression or an equation. So I've brought over the table that we had on the previous page. And if we look at it, we can see that each interval here is going up by 1. Not surprising, as we saw that in the table. So that means if we start with our equation, we're going to have n plus 11. And if we want to just check that out, of course, when n is equal to 1, then this expression would be equal to 12. When n is equal to 2, we'd have 2 plus 11, which would give us 13. And then it wants us to tell one thing that either the expression or the graph helps you see about the relationship between the two values you're looking at. So we could say that the difference between the bottom right and the top left are always 11. And we could say that the term value is equal to n plus 11. Now we're using the same square that we used in question 1, and we're describing the total of the 4 numbers in terms of the one in the top left. So the total, if we add those up, the bottom is 11 plus 12 is 23, plus 1 plus 2 is another 3, so we get a total of 26. So in terms of the top left number, total is 25 more than the top left. Now, as we move that square over 1, the total now is 12 plus 13 is 25, plus another 5 makes 30. So we'll add that into our table of values. Go back, move the square again. And this time we've got 27 plus 7, which is 34. And we'll do one more to just to check things out. 29 plus 9 gives us 38. And we can see what's shaping up here. If we look at the difference between each of these, we can see that the difference is always 4. If we're going to graph that now, be over 1 and up to 26, over 2 and up to 30, over 3 and up to 34, over 4 and up to 38. Now if we want to model the relationship, so we want to find the general term in this case, because we've got the 4 here, we're going to have 4 times n, and we want to add it to the 0 value. So if we went 4 back from 26, we're basically subtracting 4 from 26, and we'd have 22. So that is our general term. So we could say that the value is equal to 4n plus 22 if you wanted it to be in an equation format. Now we're asked to choose a 3 by 3 square of numbers from the 100 chart. So this time we're doing a 3 by 3 and describe the number at the bottom right in terms of the number in the top left. Well, in this case, we could say that the bottom right is 22 more than the top left. Now, if we again take that relationship, 1 is 23, 2 will be 24, 3 will be 25, 4 will be 26, and so on. 1 goes to 23, 2 goes to 24, 3 goes to 25, 4 goes to 26, 5 goes to 27. So now we're going to try to come up with the general expression. We look at the interval between each of these and we see that it's 1 each time, so that tells us in our expression we're going to have an n with no coefficient out front. There'll be nothing there, so just a 1 is implied. And then we're going to add to it the 0 value, and the 0 value in this case would be 22 because we're just going back one more. So we could say that value is equal to n plus 22. So again, we're asked to use the same square we used in question 3. So we're going to start off with that first 9 squares, and the total of those 9 squares is going to be 108. So the first value is 108. Let's go back to the table and see what happens when we move to the next 9. So this time the total is going to go up by 9, so I'm going to say that the new total is going to be 117. And as I keep going along, I'm basically going to be adding 9 each time. So I'm going to be at 126, then 135, and 144. I can go ahead now and plot those coordinates over 1 up to 108, somewhere about there. 2 goes to 117. 3 goes to 126, 4 goes to 135, and 5 goes to 144. So I've got my table of values from the previous page, and as we observed, this actually gives us an increase of 9 each time. So that's the coefficient that I'm multiplying n by. So I'll have 9n plus, now I want to know where does it all start. And so if I go 9 back from 108, I come to 99. So it would be 9 plus 99. Lesson summary. Sometimes two quantities are related, and knowing about one tells you about the other. For example, if you know the side length of a square, you know its perimeter. When one quantity increases by 1, and the other increases by a fixed amount, you have a linear relationship. For example, whether the side length of a square increases from 1.5 centimeters to 2.5 centimeters, or from 3.5 centimeters to 4.5 centimeters, the perimeter increases by the same amount, in other words by 4 centimeters, because you're getting 1 centimeter more from each side. This means the relationship between side length and perimeter length of a square is linear. So as we can see, since this is increasing by 4 each time, that tells us we have a linear relationship. When one quantity increases by 1 and the other increases by a varied amount, that relationship is not linear. For example, when the side length of a square increases from 1.5 centimeters to 2.5 centimeters, the area increases from 2.25 square centimeters to 6.25 square centimeters, which is an increase of 4 square centimeters. But when the side length increases from 3.5 to 4.5 centimeters, its area increases from 12.5 to 20.25 centimeters squared, which is an increase of 8 centimeters. So because 4 and 8 are not equal, obviously, the relationship between side length and area is not linear. So you can see that when we start to look at the differences between each of the values in the table. Here we had an increase of 4, but next we had an increase of 6, and next we had an increase of 8. So rather than having a constant change here, as we did up here where it was always 4, this is what tells us that we've got a non-linear relationship. You can use an equation to describe a linear relationship. For example, the relationship between the perimeter of a square and its side length is P is equal to 4s, where P is the perimeter and s is the length of the side. When a linear relationship is shown on a graph, the points on the graph could be connected to make a line. For example, this graph shows the linear relationship between the side length of a square and its perimeter. We already identified previously that that was a linear relationship. Key terms. Linear relationship is a relationship where whenever one quantity increases by 1, the other quantity increases by a fixed amount. For example, if P is equal to 4s, that's a linear relationship, and it generates a set of points like this: 1, 3, 2, 6, 3, 9, and 4, 12. Your turn. The questions were difficult to fit on screen, so you can find them all in your Google Classroom.